All right, we now have our z-score, which is a one-dimensional measurement of the sample. Basically tells us how large it is. And the question is then asking us about percentile and p-value, which are those two-dimensional measurements, measuring how common or rare the sample is. So in order to calculate those, that's where we need that normal calculator. Let's carry this information over to I have a normal curve over here. That's the one I'm looking for. Okay. So this is our sampling distribution of means. We know that it has a population mean of 1.2 years and a standard error of 0.2309, as we calculated just a minute ago. And our sample mean of interest is 1.5. So let's say that's, I don't know, right about here or so. So the first part of the question, or the next part of the question, I should say, was the percentile. We want to find the percentile for this sample. So we draw the vertical cutoff. And I want you to think, what does percentile mean? Where is it on this curve? The percentile is always to the left. So I think I can color code this. Let's do the percentile basically in a blue. Okay, so basically we've got the percentile shaded in blue there. And we want to find out what is this area. The percentile, again, is usually abbreviated as K because the letter P is reserved for p-value. So, okay, the area of that region. Now remember that when we use our normal calculator, we need to give it a minimum and a maximum on that interval. All right, I've opened up the normal calculator over here. And by the way, we can enter in the mean, 1.2, the standard deviation, in this case a standard error, 0.2309. We're being asked for an area or a percentage or a proportion, so that's the field that we leave blank. Therefore, we need to give it a minimum and a maximum. This one clearly has a maximum of 1.5. And we've seen this case before where the minimum goes off to infinity. Remember, these graphs don't end, they don't begin or end at 3, even though that's as far as we had drawn it before. But even though we're only able to draw a finite part of it, these normal curves theoretically go off to infinity. So for infinity, we're going to type in like -99. The percentile that we get from the calculator is about 90th percentile, 0.9031. So that is the percentile. It's pretty standard to round percentiles to just 2 decimal digits, 0.90. But just keep your eye on it because your homework might give you specific instructions about rounding. Okay, and then the next part of the question was p-value. How would we calculate the p-value of this sample? So again, we just have to think, where on the graph is the p-value again? It's the area of the what? It's always the area of the tail that's cut off by that vertical cutoff. So I'll go ahead and shade this one in red. And that's kind of standard practice, by the way, to shade a critical region or a tail in red. So that area is the p-value we're looking for. The mean and the standard deviation are the same as before. This time, again, we're looking for the area, so we'll leave that field blank. And this interval has now a minimum of 1.5, and then it goes off to positive infinity. So we will enter those figures here. 1.5, from 1.5 to infinity, aka 99. And we get If we rounded this to 2 decimal digits, it would round off to 0.10, pretty close to the 10%. Does that make sense, by the way? We got about 0.90 here for the percentile, and we got 0.10 here. Why does that make sense? Well, if you think about it, these two areas together constitute the whole region, so they should add up to 100%. And as a matter of fact, you can see that they do. That 90% over here to the left, and the other 10% to the right. So technically, we wouldn't have to calculate the both. We could calculate one of them, and then just subtract from one. By the way, just as one quick other note, it is certainly also possible to do this problem on the standard curve, which uses z-scores. And remember that we calculated a z-score before for this sample. It has a z-score of 1.3. So if you want to do it that way, that's fine. Let's go ahead and do that for the p-value. Instead of using 1.5 years, we could just type in a z-score of 1.3. If we do that, we're on the standard curve now. All right, I had to basically reset this thing, but if we set it to standard, then it gives us z-scores up here, with 0 in the middle and then a standard deviation of 1, which is reflected here. And in that case, we would just type in, let's do it with a between feature. We type in our z-score. We're looking for the area between a z-score of 1.3 and infinity. And that would also give us the same percentage. So we have a choice. We can either use the z-score on the standard curve, or we can use the raw score, in which case we'd have to type in the mean and standard deviation up here. We get the same answer either way. Okay, the last call of this question is, would you characterize such a result as typical, significantly low, or significantly high? So we can do that in two ways. We can either use the z-score or the p-value. The results should almost always agree with each other. So let's remind ourselves how to do that. If we're measuring a sample with a z-score, then we usually use a z-score of 2 as the cutoff between typical scores and unusually large scores. So this z-score is less than 2, and we would conclude from that it's a pretty typical sample. Right? On the normal curve, we don't really get to the unusually large ones until we get to about here, two standard deviations away from the mean. 1.3 standard deviations is not that far above the middle. And then, of course, we can also evaluate this using the p-value. Again, in this case, we got a p-value of 0.10 for that area. 10%. But as a default, we usually use 5% as a cutoff for unusually low. So you can basically see that here when the z-score is 2, this area is pretty close to 5%. But the area that we're cutting off is bigger than that because we're closer to the middle. So being in the top 10%, by statistical standards, that's not really all that unusually large. So by that account, by that measure, we also find that it is not significantly large. So basically our standard is if that value is more than about 5% as our default, again, it's a pretty typical sample.